Here's a number, 145. And then here's another number from the year before, 19. Those are confirmed harmful algal bloom events. Same lake, back-to-back years. Now here's a number that makes those two strange. 4. 4 micrograms per liter. That's the average phosphorus concentration in Skaneateles Lake, the nutrient that algae need most to grow. 10 micrograms per liter is the scientific threshold for a clean and low nutrient lake. Skaneateles Lake sits at only 4. It's one of the cleanest lakes in the entire United States. So 145 blooms in a lake that barely has the nutrients to support them. I'm Allie. I'm an environmental scientist local to this region, and NPR called me to talk about this lake. And not because everything is fine, but because something in this lake just does not add up. And when you follow the science to find out why, the answer is genuinely surprising and still a bit of a mystery. That's what today is all about. So welcome back to Aqua Diary. And if you're new here, welcome. Let me give you a quick orientation to this lake. Skaneateles comes from the Haudenosaunee indigenous term for long lake. And that's pretty accurate. It's 16 miles north to south, 3/4 of a mile wide, and about 413 billion gallons of water. It's a finger lake, which, if you're not from upstate New York, just means long, deep, glacially carved, and pointed in a way that makes absolutely no geographic sense until you see it on a map. Then it makes perfect sense. Of the 11 Finger Lakes, Skaneateles is the only one truly classified as oligotrophic. It's just a scientific term that means low in nutrients and low in biological productivity, and also high in clarity. You can see right down to the bottom sometimes. The water is genuinely and almost embarrassingly beautiful, like a lake that knows it's going to be photographed. Most cities filter their drinking water. Surface lakes are full of sediment and organic matter, runoff, and things that just require treatment. You build a plant, you run water through it, you add chemicals, you do the whole process. It's expensive and necessary, and basically everybody does it. Syracuse doesn't do that. And the Skaneateles Lake water is unfiltered. Water leaves Skaneateles Lake, travels 19 miles through gravity-fed pipelines. Gravity-fed, meaning it flows entirely downhill without a single pump involved, which is the water infrastructure equivalent of getting a free lunch. Then it drops into Woodland Reservoir, a 121 million gallon concrete basin built between 1893 and 1895. Now a national water landmark, which I didn't even know existed until I wrote this script. So that it gets chlorinated, arrives at your tap, and that's pretty much the whole process. You're drinking something very close to the lake itself if you get your water from Skaneateles Lake. And so when algae start growing in Woodland Reservoir itself, which can happen between May and October and cause taste and odor problems, the city has historically treated it with a chemical called copper sulfate. Copper sulfate pretty much just kills algae on contact. It's one of the oldest tools in the municipal water toolkit. It's effective in the way that, a sledgehammer is. You can absolutely use it and it's effective, but there might be a better tool, right? So more recently, the city moved towards ultrasound and diffused aeration, which sounds like an expensive spa treatment, but it is in fact a legitimate management technique. Ultrasound disrupts cyanobacteria's regulation of their buoyancy, so the bacteria can control their vertical position in the water column, which is something that's very unusual for a phytoplankton, or basically a tiny organism that photosynthesizes in the water. It has an internal gas vesicle, and the ultrasound works to disrupt that gas vesicle so they can't go up and get sunlight and then go down and get nutrients whenever they feel like it. And then the result is algae control without really any chemical addition. And then they also have aeration, which mixes the water column. So that calm, warm surface water condition that cyanobacteria really like isn't really happening. So the new system removes the conditions that allow the problem to form in the first place instead of responding reactively with a chemical. So why does such minimal treatment even work in the first place? Well, because the lake is genuinely extraordinary. It's one of the cleanest lakes in the world. The phosphorus only averages about 4 to 5 micrograms per liter. And again, the scientific threshold for an oligotrophic lake is 10. Skaneateles sits well below that. And again, it's the only oligotrophic lake among all of the Finger Lakes. Just for comparison, Honeoye Lake runs at 36 micrograms per liter. Visible algae blooms, murky water, year after year. Otisco Lake, one lake east from Skaneateles Lake, is at 15 micrograms per liter, with chlorophyll nearly 6 times higher on average. Otisco is a perfectly nice lake and another source of water for the city of Syracuse, but the difference is visible from the shoreline. Two things explain this. First, the Skaneateles Lake watershed, or the land area surrounding the lake that drains into it, is relatively small compared to the lake's volume. So there's not a lot of land draining into it when it rains. So there's just, in general, fewer nutrients arriving. Second, it's a pretty deep lake. Glacially carved, U-shaped, and about 80% of its volume sits below 30 feet. So cold, deep water doesn't warm up and flip over and turn around the way that a lot of shallow lakes do, to put it simply. It just kind of sits there and it keeps it clean. In June 2004, the EPA made no filtration official, a filtration avoidance waiver with basically no expiration date at all. So as long as the watershed stayed protected and the water met certain standards, no filtration plant would ever be required. So it's essentially a permanent hall pass until you get caught in a problem. So today, the system serves about 165,000 people, and some estimates put the broader service area closer to 200,000. And for 130 years, the filtration-free strategy pretty much worked perfectly. But here's what a 130-year-old track record creates: a very specific kind of complacency, not negligence, complacency. The water has always been the same. Protect the watershed and the water should be fine. And that strategy was built for a threat that comes from outside of the lake. What it wasn't built for is a threat that is already inside it. And that's exactly where the science is beginning to point. In 2017, the first confirmed harmful algal bloom was recorded on Skaneateles Lake. Scientists noted it, filed it away, and the blooms came back in 2018, and in 2019, and in 2020, and in 2021. You get my point. But for the first several years, those numbers were low. It was manageable. It was almost dismissible. Then, in 2023, 19 blooms, and in 2024, 145 bloom events. That's not really a gradual trend. That's a signal. And the intensity isn't just the count. At the peak of 2024, toxin readings at the shoreline of Skaneateles Lake hit 176 micrograms per liter of microcystin in the water, an algae toxin. The EPA health advisory for children and drinking water is 0.3 micrograms per liter. The adult threshold, 1.6. That shoreline peak was nearly 600 times the child drinking limit. Not to say that drinking water comes directly from the shoreline, but that does put the severity into perspective. Now, I want to say this clearly before we go further. Every single test of finished drinking water for residents of Syracuse came back non-detect for any cyanotoxins. The city tests weekly at both intakes throughout the bloom season, so their operation is working. The toxin is not getting through to the tap, or at least not in concerning numbers if it is. But here's why those 145 events still matter. The fact that blooms are happening at all in a lake like this, and one of the cleanest lakes in the country. And the explanation, when you follow the science, is not what the management plans are focused on. Algae need phosphorus to grow, right? And the lake barely has any. So where is the phosphorus coming from that's fueling 145 blooms in a single summer? What if it's not coming from the outside? What if it's coming from inside the lake, stored in the sediment at the bottom, waiting for the right conditions to shake it loose? To understand how that works, we need to spend a few minutes to discuss what type of organism we're actually dealing with. Cyanobacteria, sometimes called blue-green algae, although they're a bacteria, not algae, by the way, are among the oldest life forms on Earth, billions of years old. They photosynthesize. They produce oxygen. In small numbers, they are completely normal parts of an ecosystem to be expected. And if you're the kind of person who's disturbed by the idea that your lake is full of ancient bacteria, I would suggest not looking into that further. But the problem starts when the conditions tend to tip in their favor, reaching cell densities high enough to dominate pretty much everything else in the local ecology. And in some species, when they bloom, they produce toxins or cyanotoxins. There are two main ones to know about and ones that you'll hear about, and they both work a little differently. First, we have microcystin. It's a liver toxin. So microcystin is a primary toxin monitored at Skaneateles. It targets the liver, right? So nausea, vomiting, liver damage, neurological effects at sufficient concentrations, the greatest hits of things you don't want in your water. Chronic low-level exposure is where it starts to get interesting and more complicated. Epidemiological data from China, where microcystin-producing cyanobacteria are widespread in the water, found associations between long-term exposure and elevated rates of primary liver cancer. Microcystin doesn't appear to cause cancer directly, but research suggests that it promotes the growth of cancer cells that are already present in the body. The World Health Organization has classified this as an emerging public health issue, which is the WHO's way of saying, we're worried about this, just diplomatically. The most extreme documented case in 1996, a dialysis clinic in Caruaru, sorry if I'm mispronouncing, I'm not Portuguese, in Brazil, used a microcystin contaminated water in hemodialysis procedures. Of the 131 patients exposed, 100 died from acute liver failure. So now it's known as Caruaru syndrome and remains the largest confirmed human mass microcystin poisoning on the record. I include this not to alarm you, but because this is where the science comes from, and because numbers like that are how a substance ends up with an EPA health advisory. And honestly, a good thing we have that. And here's what makes all of this even more urgent. For the 1,065 homes that draw directly from Skaneateles Lake with no type of treatment at all, boiling does not remove microcystin. It concentrates it. Standard household filters don't catch it. UV treatment doesn't reliably neutralize it. Home chlorination at normal doses just straight up doesn't eliminate it. People find this really counterintuitive and they just reach for the kettle. You can't boil away microcystin unless you're, wanting to make yourself a toxin tea, which I honestly don't recommend. So what does work? Well, granular activated carbon and reverse osmosis. More on that shortly though. There is another toxin worth knowing. And I want to tell you the original scientific name for this cyanotoxin called anatoxin A before it was renamed. It was originally called very fast death factor. That name was retired for reasons that I think are fairly obvious, but it did unfortunately earn that name. So unlike microcystin, which goes after the liver, anatoxin A is a neurotoxin. It binds to acetylcholine receptors and then blocks the nerve signal that tells muscles to stop contracting. So the result is continuous, uncontrolled muscle firing, tremors, seizures, respiratory paralysis, and death. There is no antidote. And for dogs, symptoms can begin within minutes of exposure and death can follow within hours. So if you haven't put that together yet, it's really important to learn how to identify a harmful algal bloom for their lives. So how does a dog get exposed? Well, by obviously swimming and drinking that water, which is just something that dogs do, or by licking their coats afterwards, or finding algal mats on the shoreline, which can look like wet grass or plant debris, and then just eating it. A dog doesn't have to be reckless. It just has to be a dog near water doing what dogs do. The animal is doing everything right by its own logic, and the outcome is unfortunately catastrophic. There are reports of pets and people becoming ill that were documented by watershed monitoring groups. Neither the New York State Department of Health or the DEC compiles a confirmed statewide database of animal cyanotoxin deaths, so the full picture is pretty incomplete, which in and of itself is a thing worth noting. So let's go back to Skaneateles Lake here. Why is a nearly phosphorus-free lake blooming 145 times in a summer? There are 3 interlocking mechanisms that the science is starting to point to, and each one alone doesn't really tell the story, but together they explain quite a bit. And given that most scientists will admit the blooms on Skaneateles are still, a mystery, which is one of the things that makes this so scientifically interesting, and one of the things that should make anybody managing it a little uncomfortable. Well, first, the water is staying warmer longer. Every summer, Skaneateles Lake stratifies, so warm water floats on top in the summer and cold water sinks below. A distinct temperature boundary called the thermocline exists in between. Cyanobacteria love the warm upper lit surface area, and again, they can regulate their buoyancy, so they'll go up to catch the sunlight and go down and catch their nutrients in a way that nothing else in the lake can match. Give them warm, calm surface conditions and they'll take it. I like to say they're kind of like us and they like the warm, calm beach days, unfortunately. But a warming climate extends the stratification period. So earlier into the spring, later into the fall, more warm days, meaning more bloom windows. They're opportunists. So the aquatic equivalent of that person who shows up to every open bar, give them a longer window that the bar is open and they'll use every minute of it. There is an additional threat also worth naming, even if it doesn't apply to Skaneateles just yet, because it could one day. Internal loading. So in many warming lakes, oxygen-deprived deep water can cause the sediment to start leaching phosphorus directly into the water column, pretty much at the time that cyanobacteria want to use it, fertilizing the blooms effectively from below. It's a vicious cycle documented in hundreds of lakes worldwide now, and it's something that I've talked about on this show. So Skaneateles isn't there yet. Decades of monitoring by the Upstate Freshwater Institute confirms that the deeper water remains well oxygenated. But not there yet is doing a lot of work in that sentence, and there are tons of studies out there now that came out in 2025 that show that continued warming could eventually open up that pathway, even for a lake like Skaneateles. So it's worth watching, paying attention to, and not permanently disregarding. Second, there is phosphorus in the lake bed. So here's the research finding that changes the whole picture. There was a 2023 study by Brennan et al. That measured phosphorus directly in the pore water of Skaneateles sediments, like the water trapped between the grains of silt and mud on the lake bed. Nearshore sediments contain pore water phosphorus at roughly 90 micrograms per liter. The open water above them, remember what I said? 4 to 5. That's 18 times more phosphorus in the lake bed than in the water above it. So think of the shallow lake bed as kind of like a sponge. Decades of absorbing phosphorus from runoff from the atmosphere, because yes, it falls from the sky, decomposing organic matter like leaves. It's just sitting there held in place. Sit still, it holds. Disturb it, it releases. So this isn't the classic internal loading story that I just mentioned or that I've told in the past, even though it still does involve the lake sediments. Skaneateles is too well oxygenated for that chemical mechanism. So what's happening here is more of a physical disturbance, not chemical. It's about wind, not chemistry. Which brings us to the thing I find most fascinating about this lake. Every single late summer, something happens to this lake like clockwork. And now that we know it's in the sediment, it matters tremendously. And not just for Skaneateles, but for every Finger Lake trying to manage this exact problem. Strong southwest winds push the surface water of Skaneateles Lake towards the north end. And if you remember what I said before, it's oriented from a north to south direction. All the Finger Lakes pretty much are. So a majority of the wind is hitting a majority of the lake. And when the wind hits the lake like that, it's like tilting a very long and very heavy bathtub. The south end drops. The north end rises. And when the wind finally stops, that displaced water sloshes back in the other direction. And then it bounces back again, like a slow, massive standing wave oscillating from end to end across a 16-mile lake. This is called a seiche, from the Swiss French word for sway. And it can persist for hours or days after the wind has stopped. And when those seiche waves reach the shallow areas of the north end of the lake, where the water intake sits and where most blooms are reported, they physically agitate the phosphorus-rich nearshore sediments. And so the bathtub sloshes, the mud kicks up, then the wind is gone, and then the lake goes completely calm. The water is now warm, still, and suddenly loaded with a lot more phosphorus that was in the bottom about 5 minutes ago. Can you guess what happens next? Yes, a cyanobacterial bloom. And this mechanism was documented 3 times. So it was documented specifically for Skaneateles by Kelly et al. In 2019, confirmed with direct sediment measurements by Brennan et al. In 2023. So it does explain the late summer timing for algae blooms on Skaneateles Lake and why blooms concentrate at the north end. And it also explains why you can have a bloom in a lake this clean. The bloom is not drawing on phosphorus in the water column. It's drawing on phosphorus from under it. There is another possible 4th factor that I think is interesting to consider. There are about 2,000 septic systems in the Skaneateles Lake watershed, with 18 documented violations in 2014. Research at other New York lakes has found that phosphorus from old failing systems can reach through to the groundwater and persist for 35 years or more. So even after the system is gone, and still reach the lake shoreline through the shallow nearshore aquifer for 35 years. Let that sit for a second. Someone's failed septic system from 1990 might still be a character in this story. At Oneida Lake in central New York, a 2025 study found that during dry summer weeks when streams run low and bloom conditions peak, the groundwater phosphorus loads matched or exceeded what was coming from streams. Has this been directly measured on Skaneateles? No. Is it in the management plan? Also, no. Actually, I don't think it's in any management plan for any of the Finger Lakes, which is a sentence I'm stating as a scientific observation and not at all as subtle indictment. Mostly. Over the last few years, there has been a real convergence of serious science aimed at this lake. Dr. Christopher Schultz, Syracuse University. He is a paleolimnologist, which is someone who reconstructs past lake environments through the geologic record. He has studied lake basins around the world, and now he's pointing his equipment at a lake 20 minutes from his office. As someone familiar with academic research geography, I can confirm this is not always how it works. So Schultz's team is conducting multi-beam sonar mapping of the entire lakebed, a system scanning up to 1,024 beams simultaneously, distinguishing bedrock from sand, from gravel, and from nutrient-rich mud. Those mud zones are exactly where the phosphorus concentrates and exactly where that seiche energy does most of its damage. Map the mud, and you've suddenly mapped the risk. He's also drilling sediment cores, yay, because this is rarely ever done, extracting a historical narrative going back thousands of years. So the key question his team is trying to answer is, have algal blooms happened here before? The sediment record can reveal past cyanobacterial activity. That changes the management question entirely. Is this something new, driven by climate, or is this the return of a cycle that predates European settlement? The answer matters, because if the blooms are ancient, we're not preventing something unprecedented. We're just trying to stop a reoccurrence. There's also Dr. Braham Salehi from SUNY ESF. Also apologize if I pronounce that wrong. That is a college I attended, so I should probably know how to pronounce his name, but he specializes in remote sensing. So he's fusing drone imagery with satellite data to monitor water quality from above. His team is looking to develop rapid fluorescence sensors for field phosphorus measurements, meaning measure it directly in the field as accurately as possible, and installing monitoring wells that directly track nutrients coming out of septic systems, targeting the groundwater pathway that we just mentioned. So it's a multi-platform, multi-angle science, the kind that produces a data set this lake has never had before, and frankly, a lot of lakes don't. And then, of course, the Upstate Freshwater Institute. The Upstate Freshwater Institute has been running rigorous annual monitoring of Skaneateles for literally decades. So all of the oxygen, phosphorus, phytoplankton, lake clarity, their data is pretty much the scientific backbone of everything we know about this lake and its potential future trajectory. So they've confirmed the lake's continued oxygenation at depth, which rules out that classic internal chemical loading pathway that I've mentioned in the past, and directs attention squarely at these other mysterious but important to understand mechanisms. That kind of science doesn't always get released into the press, but it's the kind of science that makes every other study possible. Before I talk about what's missing, let me be clear about what is working. Because there's real infrastructure here and it does deserve credit. So there's a protection web. Who's actually doing this and what is this web? Well, the city of Syracuse runs a formal watershed inspection program. I was also an inspector in a different Finger Lake. So inspectors are monitoring for violations of the watershed rules for sanitary codes, environmental conservation law, and sometimes navigation law. So that's active enforcement and not just strongly worded guidance, although it can also be that sometimes. And there's also the Skaneateles Watershed Education Program, funded by the city and run by Cornell Cooperative Extension, and that has been operating since 1996. It connects farmers and residents and municipal officials to the science of protecting this lake. And then there's the Skaneateles Lake Association, which has been monitoring the lake for 50 years across 25 shoreline zones, among a lot of other really interesting and helpful projects. And these are not just, performative institutions. They do matter and they do make a difference. But the most unusual piece of this entire system is one that's actually why this lake has a filtration waiver, a program that most people in central New York have never heard of. It's called SLWAP, the Skaneateles Lake Watershed Agricultural Program, and that started in 1994 as a direct alternative to building a filtration plant required under the Safe Drinking Water Act. Protect the lake, keep farming viable. Both, which is something a lot of lake managers lose sight of. So this program is a cooperative effort between the Soil and Water Conservation Districts and Cornell Cooperative Extension across Onondaga, Cortland, and Cayuga counties. The USDA Natural Resources Conservation Service, the City of Syracuse, Skaneateles watershed farmers, etc. There are a lot of people involved, and it's really great work. Over the last 10 years, a good majority, about 54 farmers, have voluntarily enrolled in the program, and 44 of them have completed whole farm plans, which are detailed farm-specific environmental management plans that protect more than 150 tributaries entering that lake, and they're voluntarily doing it. Since 1994, the city has invested $21 million into the SLWAP, $14.7 million in direct funding, and leveraging another $6.3 million in grants. The program is so successful, it served as the pilot for the New York statewide Agricultural Environmental Management Program, or AEM program. So what they built for this one lake became a model for the entire state. And that is genuinely impressive and deserves more credit, if I'm being completely honest. In June 2025, the state approved the first formal phosphorus management plan this watershed has ever had, the 9-element plan. Governor Hochul directed $42 million in Bond Act and Clean Water Infrastructure funds towards the Eastern Finger Lakes, including Skaneateles, to accelerate implementation. The 9E plan is real and is new, but some of the science has already moved past it. Those two things are true simultaneously, and here is why. The 9E plan uses watershed modeling tools, and this one in particular is called SWAT, the Soil and Water Assessment Tool, to estimate phosphorus runoff going into the lake. It's a useful planning instrument, and it's also a model. And models are estimates, not hard measurements. And the scientific literature is pretty direct about this distinction, even when the public conversations around it often aren't. Research reviewing SWAT performance across phosphorus-impaired watersheds found that while most models perform well for hydrology and sediment, many are rated unsatisfactory, I don't know why I'm saying it that way, for nutrient loads, specifically for soluble reactive phosphorus. That's the form that algae or cyanobacteria typically prefer. There's also a documented pattern where SWAT models can disproportionately attribute phosphorus loading to whichever land use tends to dominate that watershed. So in a largely agricultural watershed like Skaneateles, Owasco, and many others, that often means that agriculture absorbs a larger share of the modeled load or the blame than the physical measurements sometimes can support. That's a known limitation in documented peer-reviewed literature. It's not a secret. It's just not always discussed. But the deeper issue is this. The 9E plan models phosphorus entering the lake from the watershed. It does not model phosphorus rising from the lakebed. No direct measurement of phosphorus flux has ever been done for Skaneateles or for most of the Finger Lakes. We don't know how much the Seiche disturbance pathway contributes to the phosphorus budget. And without that number, the budget is pretty much incomplete. That's not an opinion. That's a legitimate management gap after what the science is finding. And the next version of this plan should try to fill it. There's also questions that I've been asked about the intake extension and the filtration waiver. So the city of Syracuse is looking at doing a $16 million shallow intake extension. So the pipe that brings water in from the lake. And so it's a project to move the shallower of its two intakes to a deeper depth. At only 20 feet below the surface, the existing intake has had to shut down an average of 11 times per year over the last decade due to turbidity from wind and sediment disturbance, because yes, there are regulations on how dirty your water can look. Moving it deeper reduces that exposure and can also mitigate some algae toxin concerns. The project was in permitting and final design as in 2025, but I wasn't able to find any updates on this when I looked into it. The project description notes that the $16 million extension is only a fraction of the estimated cost of a filtration plant, which naturally should invite the question, how much would a filtration plant actually cost? In 1996, a filtration study estimated construction at $60 million, with annual operations around $4 million, versus the then current operating budget of roughly $1 million per year. Inflation adjusted to 2025, that construction estimate is roughly $120 to $130 million. So annual operational costs could multiply current water bills fourfold or more. There are directional estimates based on public data, but the actual figure would actually depend on financing grants and the rate structure of how they went about this. No one wants to find out to water rates if the filtration avoider is lost, but it's something people are worried about, as they should be. And more ironically, if this filtration waiver is lost, it could also strip some of the funding that's allowed Skaneateles Lake to be so clean. All of those interesting management programs that we talked about, a lot of the motivation for doing them is because there's a filtration waiver and there's skin in the game to keep that lake clean. So let's hope they don't lose it. So what does this mean for you on a practical level? If you drink city water, if you're a City of Syracuse customer or receiving water through Jordan, Elbridge, or DeWitt, your water is tested weekly for cyanotoxins pretty much all bloom season. Every 2024 test in the finished drinking water was non-detect, so nothing to worry about yet. The operation is still currently working as far as we know. But you can stay current through the New York State DEC websites and county health advisories. There's no immediate problem, but it is worth paying attention to still. If you have a private intake, completely different story. About 1,065 lakefront homes draw water directly from Skaneateles Lake. And the city's treatment system does not protect you here, right? You're on your own, and therefore you're in the highest risk category. And I want to be specific again about what that means if you weren't listening before. You cannot remove algae toxins by boiling it unless you want a liver toxin tea or a anatoxin tea. It sounds kind of nice, but it's not. Yeah, boiling concentrates those toxins, so please don't try it. I don't know why the boil water in a crisis is so deeply ingrained into people's brains that it overrides all logic, but you have the same volume of water with a higher concentration of toxins, and then you get rid of the water. You get my point. The kettle is not your friend here, so please don't try it. Standard household filters also don't catch cyanotoxins. And you can use granular activated carbon or powdered activated carbon or reverse osmosis, but if there is an active bloom on your shorefront property, I would not recommend using that water at all. Regardless of what system you have, there is no independent testing on these private intakes to make sure that you're safe, or especially if you have pets. So just don't risk it. If there's a do not drink order or an obvious algae bloom out front, just don't. So swimming, recreation, and your dog. Check the DEC's bloom tracking site before your swim or to understand the history of where the blooms are and when they've been, right? That is dec.ny.gov/HABs for harmful algal blooms. Or you can look for green paint-like foamy or scummy water or creepy turquoise lake lattes. If you see any of that, please stay out and rinse off if there's any accidental contact. Keep your dog out of bloom water. Just straight up don't risk it. Keep them away from shoreline mats that could be dried algae. Dogs drink when they swim. They lick their coats afterward. They will eat things off of a shoreline that'll give a human pause. We know this. And with anatoxin A in particular and the possibility that it's there, symptoms can begin within minutes and there is literally no antidote. So your dog is not being reckless. Your dog is being a dog, and it's our job now to know the water for them. So if something looks off, you can also report it at hab.report@dec.ny.gov. You can send them a picture and they'll tell you if it's a bloom. The monitoring system only works if people are using it and saying something when they see something. So I highly suggest you do. All right, so I was also asked about fish advisories. Skaneateles has no current water body specific fish advisories. So anglers should just follow the updated 2024 New York State statewide species specific advice based on mercury data. which is another episode I'll do on how we get mercury in our fish. One important watch item I will mention, though, is the DEC collected PFAS testing samples from Skaneateles fish in 2023, and as early as 2024, those results were still being processed. If you haven't heard of PFAS yet, it's one of those emerging contaminants that's a forever chemical that has a lot of concerns and will also be another episode here at some point. So stay tuned. But the DEC has never previously tested Skaneateles Lake for PFAS. Until those results are published, anglers eating their catch regularly should still check in with health.ny.gov/fish for any further updates. There is a chemistry problem too I want to tell you about in the water treatment plant that I pretty much never hear discussed outside the water treatment industry, and it involves the very thing that we use to keep our water safe in that process. So here's the part that I tell you that fixing one problem can create a very different one I need you to know about. Chlorine, the thing that kills pathogens and keeps drinking water safe, which I'm not saying we don't need chlorine, we 100% do, by the way. But chlorine can react with natural organic matter in water to form a category of compounds called disinfection byproducts, or DBPs. The most studied are trihalomethanes, otherwise known as THMs, and haloacetic acid called HAAs, or sometimes you'll see them as HAA5, but I honestly wonder if it was meant to be an S. I don't know. I'm not a chemist. But scientists have now identified over 700 different disinfection byproducts, or DBPs, in drinking water. And for reasons that I have to assume involve a lot of paperwork, we only regulate a handful of them. European meta-analysis found bladder cancer about 45% more prevalent among people consuming chlorinated water with elevated THM concentrations. So disinfection byproducts have also been associated with reproductive effects. This is not like some kind of weird fringe concern. It's in the peer-reviewed literature, and it's why the EPA has maximum contaminant levels for THMs and HAAs. Here's the Skaneateles Lake connection. Cyanobacteria blooms increase organic matter, right? Like they are just a bunch of cells. So more organic matter means more potential for disinfection byproduct formation when it comes in contact with chlorination. For this lake in particular today, it's just a watch item, not an alarm, but I will tell you next door to the west in Owasco Lake, my drinking water source, it was a problem. It was an exceedance from what the EPA advises, and we were notified in the mail. So it's not a distant problem. If you're on Skaneateles or Syracuse, it was your neighbor's problem. So it's a watch item. It's not an alarm. But it is the right question to be asking before the organic load climbs further and before this becomes an actual problem. So even if you're not in the Skaneateles Lake watershed or getting your water from Skaneateles Lake, you can still check and see how your home water system is doing when it comes to this. You can look up your town's annual drinking water report and find the section on tested contaminants and look at how close the THMs and the HAAs came to the EPA's maximum contaminant level, or MCL, which is how much the EPA has decided you should be exposed to. If they're close to that limit, that MCL every year, that's worth keeping an eye on. And so whether you get your water from Syracuse or not, definitely something worth checking out in your annual drinking water report. Normally you can just Google your town and consumer confidence report or annual drinking water report, and you should be able to find it. So I want to leave you, not completely yet, but with a reminder, a scary story that might not be so far away. So let me set the scene. August 2nd, 2014, Toledo, Ohio. An emergency alert goes out. Do not drink the water. Don't cook with it. Don't boil it. Don't give it to pets. You want to go to a restaurant? No, those are closed. A cyanobacterial bloom that produced microcystin, that liver toxin that we usually talk about on Lake Erie, had grown directly over the water intake. It overwhelmed the city's treatment process, their 8-phase treatment process, and the toxin entered the distribution system. 400,000 people were without safe tap water for 3 days. The National Guard was even activated. The National Guard, yes, for water in an American city in 2014. Toledo had a filtration plant, and it still failed. Skaneateles does not have one. So the situations are different, right? And I want to be fair about that. Toledo sits on a more shallow, heavy, nutrient-loaded western basin of Lake Erie. Phosphorus concentration orders of magnitude are quite a bit higher than Skaneateles. So the dynamics and the situations are not equivalent, right? This is not like some kind of prediction. It's a lesson. The lesson is waiting for a crisis before asking the hard questions is not a strategy. And hiding stories like this from the public is also not ideal. Toledo didn't see that summer coming, not with intensity, not that year, and we have time right now. The question is whether we use it and whether we make the people aware. I can understand the sentiment behind not causing public alarm and public panic, but there is a balance between preventing public panic and not being completely transparent with the real risks here. So the blooms aren't happening overall in Skaneateles because somebody just started like dumping phosphorus into this lake. They're happening because warming weather is extending the season when a specific physical mechanism, that sheesh, shakes loose the phosphorus that's already stored in the lakebed. Those tools we have were built to reduce what comes in from the outside. The evidence is starting to point to the problem that's already inside the lake. And there's still so much to learn. Before we close, I want to mention something deliberately that I did not cover in this episode that many of you asked me to. Not because it isn't relevant, it absolutely is, but because it deserves its own space for the story. And I refuse to just give it 3 minutes and an overview of what's going on with Skaneateles Lake. You may have heard that Micron Technology is building a $100 billion chip fabrication complex in Clay, New York, just north of Syracuse. It's one of the largest semiconductor manufacturing facilities ever built in American history, and they came here because of our abundance in water resources. So chip fabrication uses an extraordinary amount of water, and like ultra pure water to be specific, the kind you produce by stripping everything out of it, including things that like minerals that some people might prefer to keep. The process also generates a significant amount of wastewater. These facilities run essentially around the clock with water demands that would make a mid-sized city pretty uncomfortable. So where does that water come from and where does it go? The answers involve Skaneateles Lake in some ways and the Onondaga County water system and a set of infrastructure decisions that, as of this recording, are still being actively worked out. The environmental review in some ways is still kind of ongoing, and the scale of the facility means that the decisions being made now will shape water demand and water quality across our entire region for decades. I'm not going to speculate on outcomes, but I will make sure I cover the story factually on this podcast. So that episode is coming. I am still researching it. I am still writing the scripts. So subscribe wherever you're listening or follow the show because that one is going to require your full attention. And I'm not being dramatic. I'm just being thoroughly accurate here. So where does this leave us? And what is working? Well, the city's water operation for now, weekly toxin testing for bloom season, $16 million intake extension and moving through the approval process and the planning process, the 9-element plan, first of its kind, backed by a $42 million in state investment, the 9-element plan, 50 years of Skaneateles Lake Association's monitoring and planning, the SLWAP's 30 years of farm-level environmental work, which became a model for the entire state because it works so well, the Shoals sonar mapping, the ESF research effort, Cornell Cooperative Extension's watershed education program since 1996, the Soil and Water Conservation District's work, and the community around the lake talking about lake problems and doing their part in keeping it clean. The science community is paying attention, and now so are you. So what's missing? A direct measurement of sediment phosphorus from the zone's shoals has now mapped. One study, one field season. It would tell us whether the lakebed is contributing more phosphorus than the entire watershed combined, which without that number, the phosphorus budget is incomplete, and the 9-element plan is managing incomplete accounting. That gap is identifiable, fillable, and currently unfilled. About 1,065 lakefront homeowners with private intakes need outreach before bloom season. And cost share programs for activated carbon or reverse osmosis at those properties would be a pretty good immediate step at protecting the highest risk population right now. Although I won't mention using that only if you're in that situation, but like it could help, right? Like they're always going to have some number of uneducated, and I don't mean that in like a rude way. I just mean people that aren't aware of how to identify a bloom and people that aren't thinking about it, because sometimes this information is harder to find than it should be. And then we also have the wind data, the sediment data, and the sonar maps are being made. The pieces all exist. So what remains is the will to keep asking the right questions and to update the plan to match what the science begins to show, not the science we just had from a decade ago. So the science exists. The gaps are fillable. People working on this lake are capable of closing them. And we've got a good team of people looking at this lake. The wind and sediment don't really care about our management categories, though. And a lake that's important to upwards of 200,000 people and their drinking water to recreation and the region's identity deserves management that matches what the science is finding. And I hope we continue working towards that. So I'm Allie, a Finger Lakes local and an environmental scientist. This is Aqua Diary, and if something in this episode surprised you, well, that's exactly why I'm here, and I'm glad. So share this with your people, leave a review if this was helpful, and I'll see you for the next one. And I will talk to you soon about Micron. You have been warned. Have a good day, guys. Thanks.